I'd like to introduce Andy Kamasian from Southern Fabricating Machinery Sales, just outside of Tampa. Hi, Andy.
How you doing, David?
Everything is good. Andy, I'd like to talk to you today about sheet metal shears. You're in the metal fabrication industry, and you're a specialist in this kind of stuff. Tell me about shears, what they do, and how they work.
Well, the shear is a metal cutting device typically used for, or solely used for, sheet metals. It's used to size up sheet metal into smaller segments for working. That can be the first process of many processes that are used in a sheet metal fabrication shop. But it's typically one that is used for materials from anything from a 1/2 inch thick on down, and any type of material that would be used in sheet form.
And you're cutting straight lines, kind of like a paper cutter.
Absolutely. It's cutting straight lines and able to size up material. Quite a useful piece of equipment, and still very, very useful in the shop today.
As an appraiser, Andy, what I find fascinating is I can go into a fab shop and I could see a Cincinnati shear from 1965, just to grab a year, and it's cranking away. Mechanical shear, and it's banging out parts, and they're in tolerance. What's changed over the years in a sheet metal shear from those machines that are still out there, cutting metal?
Well, shears they're powered by a variety of methods, and the simplest method is by the foot. There's a very small machine called a foot shear or stomp shear, and that machine is a very light gauge machine, typically very small. And as they grow up in size, they go up to an electric powered shear, where an electric motor powers the shear blade to bring it down. Again, the very thin gauge material, typically used for roofing applications and some trim, remodeling trim work applications. The next step up, and the biggest majority of shears that you'll find, are powered by hydraulics. And hydraulics were not the first choice for manufacturers, but they were the cheapest choice. So powering something with hydraulics was relatively easy to do and relatively inexpensive to do. And of course, the shears that you mentioned, the mechanical shears, were the first choice built. The original shears that were built were of a mechanical design. And those shears are still very valuable today and very desirable today in the right models. They're still made today, even though a comparable mechanical shear will be 4 to 5 times the price of a hydraulic powered shear, an equally equivalent size hydraulic shear. That mechanical shear is still very, very desirable because of the durability and the longevity of it. And companies that run shears nonstop, every day, all day, good example is steel service centers, love the mechanical shear, and they're willing to pay 4 to 5 times the price for that machine, knowing the life and the durability they'll have.
Very interesting. When you talk about chip making and 5-axis and complicated aerospace CNC, machines that are making these crazy looking parts, CNC and computer numerical control has a big part in making those kinds of parts. Has CNC changed shearing that much?
Oh, absolutely. It's, computer numerical controls have infiltrated almost every sense of manufacturing. And with a shear, the typical controllable axis is the back gauge. And that gives us the length of piece of material that we're going to be shearing off, or what we call the drop. And so when we shear, we can have that drop in any size we want. Well, it's easy enough to just move the back gauge to a given position and make the shear cut. But if you want to take it a little bit of a step up, you can make a kit of parts. You might have 3 parts that are 6 inches, 4 parts that are 8 inches, and a few parts that are 10 inches. And you can have that blade cycle up and down in the shearing action, and the back gauge automatically respond after a certain number of cuts. Makes the operator's job quite a bit easier, and it certainly makes the accuracy of the shear better as well.
And in the old days, they had to dial that back gauge to the spot that they wanted it and then measure it.
We've got an old term in machine tool sales called FOPBG, and it's called front operated power back gauge. And it's really from the 1950s, because that's when the back gauge first became front operated. And boy, when somebody put an electric motor on that, so you just have to push a button, that was the greatest thing ever. And today, those are all controlled CNC. So even though you might still see that front operated power back gauge nomenclature, it really is a CNC controlled back gauge. They're doing the same thing now on shears with front gauging. And front gauging lets us do just something a little bit more accurate than the back gauge. The back gauge is just a long steel bar back there that we use as a bump stop. Front gauging uses a couple of small points. We'll call them fingers that come up, and they're quite a bit more accurate. So when I want very accurate blanks, something that I might take right from the shear over to a press brake to form, that front gauging does quite a bit better job. And that option typically is something that a real precision fabricator will not only know what it is, but he'll definitely want that option on his shear.
What else do we look for if we're buying a used shear? What's important based? I know it's a crazy question because it depends on the application, but in general terms, can you share what do we look for? What are the wear parts, and how do we know we're getting a machine that's functioning well?
Well, I mean, just like any other machine, looking at the fit and function of it, the big thing with shears is you want to look at conditions of the blades that are on it. You're going to get a good idea how well the shear was cared for and maintained. Another really big factor of shears is what's called the hold downs. And these are the hydraulic or mechanical stops or pressure points that come down, pads that come down just in front of the blade to hold that sheet of material flat as the blade then comes and slices through it. Those hold downs are critical in the operation of the shear, and they often fail. Either they're hydraulic and they spring a leak, or they're mechanical spring action and they fracture a spring. So that is something to really take a look at. If the blade is good and those hold downs are good, there's not a whole lot more going on the shear itself other than the back gauge that you really need to be too concerned with. They're a pretty durable machine.
And they're generally described and measured by what kind of nomenclature or dimensions?
Well, all shears are sized. They're sized by the thickness of material they can cut and the full overall width. So typically a 1/4-10 shear would mean 1/4 inch material, or 6 millimeter, by 10 foot, 120 inches of capacity. One of the common misconceptions too that folks might want to be aware of is if you have a 1/4 inch shear, it doesn't cut 3/8 material. A lot of people think that, well, can I cut just a little bit of 3/8 or a little bit of 1/2 inch? No, you can't. The reason is the blades are angled. And as those blades are angled, you'll have a flat blade and your blade angled at just about 1 degree. It can only engage that material for just a short period of time. If you add thicker material, you'll end up jamming the blades together. And on a mechanical shear, that can be quite a problem to get apart. On a hydraulic shear, you can actually lock it up, and typically those have safety valves in them, which will actually blow out the downward action. In other words, relieve that pressure and allow you then to stop and reverse it and back it up. So it's just one common misconception. If folks are looking for shears and they like a wonderful 1/4x10 shear, but they've got a little bit of 3/8 to do, you need a 3/8 shear. Go ahead and spend the extra money for the right machine.
Always sage advice from Andy Kamajian at Southern Fabricating and Machinery Sales. Really useful information. Andy, thanks so much.
All right.